Hi, my name is Lauren, and I am a co-founder of Parlay, a Meteor mobile app for challenging your friends. And my talk tonight is about how to improve your Meteor app's render performance. I'll start out with a background of website performance in general, and then I will show you around the timeline tab in Chrome DevTools, and then we will analyze a website telescope, and then I'll go over different techniques for improving your render performance. So to start out, back in the olden days, uh, when you wanted to show the user a new page on your website, the user had to click a link or click a button that would that would trigger the browser to request a new page from the server. The browser would say, "Hey server, give me a new HTML page." The server would generate it and then respond with it, and the user would have to wait for that network time to complete before the user could see the new page, and that was often slow. And so one way to speed it up was to, instead of requesting a new HTML page, have JavaScript render the new HTML in the browser, and that gave rise to single page apps like Backbone or like Meteor. And in SPAs, or single page apps, the first time the user goes to the website, they get a big bundle of JavaScript that has compiled HTML templates in it. And then every time the user sees a new screen, then that's JavaScript compiling the template into HTML or into DOM and putting that in the page. And that often takes much less time for the JavaScript to run than for the browser to request a new HTML page from the server. And so with SPAs, we have different performance problems, similar but different focus. So in the olden days, everything was about page load, because every time the user saw a new screen, there had to be a new page load. For Meteor, it's you only care about the page load time for the first time that the user opens the app, but most of the time, the user is just waiting for JavaScript to run. So and it usually takes less time for JavaScript to run than for you to do a separate HTTP request. So we are in Chrome Canary right now, and which usually has a slightly newer version of Chrome DevTools. And we're usually, as developers, looking at elements and console tabs, but there's also a timeline tab. And here's how it works. You capture a recording, and right now I have selected JS Profile, which will give you the names, starts, and end times of each JavaScript function. And then I have Paint, which is browser rendering, and screenshots, which are the current status of the screen. And we can clear the old one and start recording a new one. And then I'm going to refresh this page. Wait for everything to appear, and then hit finish. And then I'm going to use my mouse scroll wheel to zoom all the way out. And we can see this line right here is the page load. So before here is requesting all the HTML and JavaScript and CSS. And that's not very interesting right now because I am loading this locally. This is a development version of Telescope that I'm running on my machine. And up here we have the screenshots. Before here is just the previous page, which looked the same. Here is after we've loaded the new page. And then here we start seeing the page, but you notice that the YouTube videos aren't on the left side, and the author avatar isn't on the right side, or the comment numbers. And then progressively, as we move the cursor to the right, we get newer screenshots. And at this point in time, you see that more of the full page has been filled in. You can see the YouTube screenshots on the left. Below here is the seconds, from 0 seconds of when I started the timeline to 10 or 11 when I stopped it. And right under there are the frames. So a frame is a single picture of pixels that is painted by the browser to your screen. And so there was one page that was painted at the end of 2.5 seconds after page load, and that was the screen right down here. And you can see it's incomplete. And then the next frame took 1.5 seconds to finish putting on the screen, and you can see how it looks like. And then you can use the arrows to go back, and right and left arrows to go back and forth between different frames. And you can see in this frame we have everything. Below the frames, you can see what's taking time, and that's color coded. Orange or yellow is JavaScript, and when you click on one of these rows, you can see the location of the JavaScript, how long it took, and you can see the function names in this tree, which is called a flame graph. So first, this called onGlobalMessage called anonymous functions, eventually called render, which called one function, and get root DOM node, and then called blaze.render. So you can sort of get a sense of what's going on by looking at the function names in these bars of the flame graph. So we can see that starting out, we are blaze.rendering immediately after page load. And sort of stepping back for a moment and looking at Meteor performance in general, not necessarily render performance, thinking about what is the browser doing when, say, the user clicks a link and tries to get to tries to get to a new page. Often what's taking the most time is not actually browser rendering, but is waiting for new data to come from the server. For instance, if you have a template level subscription, or if you are in Iron Router doing a wait on, then you are waiting for the server to send new data to populate your mini Mongo collections on the client over DDP, and that can take a while. So that usually is taking most of the time. But in some cases, you don't need any new data or in order to display the next page, and in those cases, the delay is usually completely taken up by JavaScript or Blaze doing rendering of the compiled JS templates into the HTML that it puts on the page. So here we can see that often in a default Meteor app, if you subscribe to something in a wait on, then after page load, after this green bar, you're going to have some blank space while Meteor is waiting for the subscription to complete, for the data to arrive over the network from the server, and then you'll see yellow JavaScript running. In this case, Telescope is using a package called Meteor Hacks Fast Render, which includes most of the data in the initial page load, so it doesn't have to do that waiting. So it's starting to render right now, or right away, and that is a 2.3 seconds total time to render this first page, which has almost everything in it. So the data, for instance, the post name and tags and author was all included in that first page load. And let's see. So this big thing is Blaze rendering that first part. Let's see what is going on in the flame graph after that's done. So here we have DDP client, ws.onMessage, which is WebSocket on message. You can see sock.js, clues you into the fact that that's a WebSocket. And then down here we see local collection.update. So we are updating Minimongo based on data we are getting from the server over this WebSocket. And you can see that these other columns of function calls are similar. They all look the same. They're all this WebSocket.onMessage. And that goes on for a while up until this function call. So most of this 1.5 seconds. And then at this point, we have a helper running. You can see this is template.categories menu, so this is the name of the template, and it's running a helper called menu items. And we will come back and look at that later. But after it's getting all the rest of this data, then it is doing this frame, which has everything. So most of the data we had initially starting out in order to paint this, render this screen, but some of it we needed, and we got over the wire here in order to paint this frame, which has everything. So one thing we could do to speed up the time at which you see all of the content, including the YouTube and the avatars, would be to instead of having this data come right here, have it included with fast render on page load. And that is most of the page load analysis. So let's go back. We talked about the parts of the timeline tab, and we did the 3A telescope page load. Now let's look at a route change. So what happens when we go to a new URL? Let's go to the About page, and I'm going to click that again just to see how long it takes. 3, 2, 1, click, and appear. So it takes maybe a second to load. You can notice the delay. The average person notices delays that take 100 milliseconds or more. So your target in responding to the user to make it appear immediate is under 100 milliseconds. Since we noticed that was clearly over 100 milliseconds. And let's measure how long it takes using the timeline recording tool. So I'm going to go back to the index. I'm going to clear this recording, start a new one, hit About, wait for the page to change, stop the recording, zoom out with the scroll bar, and we can see what happens. So the main thing that's going on is this click event. Usually when I'm looking at a flame graph, I look at the top to see what triggered it, in this case the click, and then I look at the bottom of the graph to try to find identifiable function names to see what's going on. So in this whole the click event took 880 milliseconds to complete, and looking down into what's going on, we see we're in Blaze, and we have a blaze.destroy view. So assumably we are taking that index page that we had and taking it out of the DOM, and this takes 59 milliseconds. It does often takes much shorter, but the index for Telescope had a good amount of content in it. So that the time it'll take to destroy is sort of proportional on how much content you have on the page, and how complicated like the events and helpers are. Probably just events. And then we have some more stuff going on. Materialized DOM. So it looks like maybe Blaze is starting work on creating the About page, the new page. And then we have most of it is taken by this column here. And let's try to find an identifiable function name. Here we have the categories menu helper named menu items. And what are we doing inside of menu items? we are doing a local collection cursor fetch, and then we are doing a map. So this is doing a Meteor collection fetch locally, and then we are assumably mapping over that collection, and then doing other mini Mongo queries based on that, and then we are doing it all over again. Another fetch, another collect. And if we want to see what's actually going on, we can look at the function. Since we are in local development, the JavaScript is not minified. So Chrome Dev Schools can show me where it is and what's going on, and I can actually read it. Let's see. So menu items, this is a helper inside of the categories menu template, and I'm doing a categories.find, and then I'm doing a map. So when you're looking at this, you can see, oh, okay, this is the code that's taking most of the time here. What can I do to improve that runtime? And since so much time is it seems to be taken up by mini Mongo queries, doing probably a .count on everything in that category. Sorry, so just to connect this with what's on the page, the categories menu is up here, and it has different categories and subcategories, and it looks like it must be calculating the counts of how many posts are in each category. So one way to speed that up would be to, instead of doing a .count on a cursor, you could store with the category the count of posts in the database. So sort of denormalizing that data. But we should actually, instead of thinking about how to speed that helper up, we can take a step back and think about whether we need to be running this code at all. And we don't, because this categories menu is the same categories menu that is on the index. So we already have it there in the DOM. We don't really need to re-render it. What's going on right now is that the entire header is being removed and re-rendered and added to the page when we switch routes. But it would save time from the user perspective if we just left the header in the DOM and just rendered the about page, which is pretty simple. Doesn't even have any data in it. And one way to do that, leaving a template in the DOM, is using, for instance, Iron Router's layout template. You can also do a template.dynamic. Let's see. So hopefully we can take that out by just leaving that in the DOM. That would speed this up a lot. One other thing to note is that when we did the click event, we immediately started scripting. So we know that we're not requesting any data from the server. We're not waiting on any collections to be populated or subscriptions to be ready. Often, if you had a template level subscription or a Iron Router wait on, then you would first see the click event, and then you'd see empty space for a while until the data come on the wire, and then you'd see a block of yellow JavaScript. So what I did was I looked at I looked for categories menu, grepped the code base, and I found this template. And if we comment this out, we can sort of see how long it would take to render without this helper being called. So I'm going to record, and then go to the About page, and then stop. The last one took 880 milliseconds. Let's look at how much this one takes. Here's the click event, and the total runtime is 100 milliseconds. so that rendering the header, and especially that categories menu, took the far majority of the time, and now we're almost at our target of under 100 milliseconds for the user not noticing the time difference. So that's great. We have the faster route change now, and let's look at some other techniques for improvement. This is a Medium essay that I wrote, and I go into depth about a number of different techniques. One of them is to leave things in the DOM, like we were talking about the header. Another thing you can do is say when you're loading the page, render both the index and the about page. Hide the about page with CSS, and then when you do the route change, hide the index with CSS and show the about page with CSS. So that and doing like a display hidden or display block visible is going to take much less time than it would take for JavaScript to render the new template. One problem you can get into when you leave a lot of things in the DOM and are just showing and hiding them is that the DOM can grow to be very big, and when it's big, it takes longer to do everything like doing like query selector or adding or removing things, and it can take a lot of memory resources. So when you're on a memory constrained device like a cell phone, it can crash the browser. So if you run into that issue, then there are some more techniques. One is off-DOM rendering, which is used in Rocket Chat, the open source Slack alternative built with Meteor. And in that, with that method, you render the template with JavaScript, but you leave the rendered DOM nodes just in JavaScript memory. You don't put it in the DOM until you're ready, until the route change. And then when you leave that route, instead of completely destroying it, you take it out. You take it out of the DOM, you take it out of the page, but you leave that DOM tree, that virtual DOM tree, in memory, so that you can just add it back to the page when you go back to that route, instead of doing the entire Blaze rendering process. Another thing you might run into is if you have too many computations going. Computation is if you write tracker.autorun, or if you have helpers, but which are by default reactive. Each of those is a computation, and if you have a lot of them, then you can run into problems. If you do, then you can use this package Meteor non-reactive rendering, which will allow you to render a template without anything in the template being reactive. So you're not going to get reactive updates, but for some views that might be fine. Another thing you can do is render fewer things, and I'll show an example of that in my app, Parlay. So Parlay is an app for challenging your friends. Say $5 that I will lose 5 pounds this month, or $10 that Trump will win the election. And this is my profile tab, where I have a list of all of my what we call parlays or challenges, and there's 122 of them. If I displayed all 122 of them in a list, then that would take forever to render. So you want to paginate. So render fewer things is gonna reduce the amount of time it takes for the page to appear to the user. And the probably the nicest way to do pagination is with an infinite scrolling. So you can see the scroll bar size at the moment is pretty small. So when we get down to this loading spinner, as soon as the browser recognizes, or in JavaScript you get the scroll event that goes down that far, then it tells Blaze to start rendering a few more challenges. And you'll notice when the when you get down to here, I can't scroll until Blaze has finished rendering the rest of them, and it takes a second or two for Blaze to do that. We can show that again. Let me grab the scroll bar, go down. I try to go up and down, and it's frozen for a second. So that's another reason, besides just waiting for the view to change when someone's going between pages. That right there is another reason why you need to consider render performance and get it down, because the user is going to think that the screen is frozen, and they're going to be like, bad user experience. Okay, so another way in which I render fewer things is that if you go to the friends feed, they're not rendered to start with. You see that spinner to begin with, and right when the user taps that tab, then it starts the rendering process. Note that it would have taken longer if I didn't have the data on the client. So in the initial page load, I don't just subscribe to the data that I need for my profile. I also subscribe to the data that I need for the friend feed and for the public feed. And I use a package called Meteor Hacks Subs Manager for that. I highly recommend that. Another technique, well, actually, so at the point where you have things you need to render and they're still taking a long time and you can't fix it, one thing you can do is distract the user to let them know that the screen is not really frozen, that the app is still working. You can move something on the current page around while Blaze is busy rendering the next page. And there are a couple of examples of ways in which I do that in this app. So notifications right now is not infinite scrolling. It's all of them ever. So it takes a long time to load, and it also takes a long time for them to be taken out of the DOM when you go back to the index. So when I tap the back arrow, if nothing happened, then the user would think the screen is frozen. But I do a waves effect, waves ripple, to show that yes, this was clicked, even though it's going to take a second on desktop and more than a second on mobile to go back to the index. Another example of that is if you tap a person to open up their profile, the profile can take a while to load. So what the first thing it does is it takes the picture on the current page and transforms it bigger and toward the middle where the profile picture is going to appear. So I click, it moves, and then the overlay appears rendered. And you can notice the delay between when I click this and when the overlay appears. And so the user would be confused or think that the screen is frozen again if nothing was happening on the screen while it was waiting for this to render. So I think that is everything. Are there any questions?